Okay, this is a problem from MyOpenMath, and it says Tom's an amateur motorcycle racer, averages 129.94 seconds per 2.5 mile lap in a 7-lap race with a standard deviation of 2.28 seconds. The distribution of his race times is normally distributed. So whenever it says normally distributed, bell-shaped curves. We are interested in one of her randomly selected laps. And it says round all answers to 4 decimal places and let x be the number of seconds for a randomly selected lap. So the first thing is what is the mean and the standard deviation? And you guys had this before on other problems, and it seemed like we were doing okay. So again, your mean and your standard deviation, the mean up here is 129.94. And the standard deviation, it says, was 2.28. The next part on here says, find the proportion of her laps that are completed between 126.18 and 127.24 seconds. So in order to do this is part B. I'm going to draw a normal bell-shaped curve, especially for those of us that are a little bit more visual. Helps to be able to see this. On my normal bell-shaped curve in the middle, I'm going to write the mean, which was right up above here, which was 129.94. And then I'm going to go ahead and put my numbers in that I have. And the numbers that I want between this time are 126.18. So 126.18, and the other one is 127.24. So between these, I'm going to shade. Again, because it's normally distributed, we will use normal CDF, and that's going to be the probability that our value of x is going to be between 126.18 and 127.24. Using normal CDF. And normal CDF is going to be your lower bound, your upper bound, your mean, your standard deviation. So lower bound, where the shading starts, is 126.18. Upper, which is where it ends, is 127.24. Mean is the 129.94, and then our standard deviation is 2.28. Putting that all in on your calculator, rounding your answer to 4 decimal places, you get 0.0686. Part C says the fastest 4% of our laps are under so many seconds. So we're going to go ahead and draw a bell-shaped curve for C. And again, our mean is 129.94. Faster times means that the time isn't going to be greater than, it's going to be less than. And so we're actually going to be on the left over here. So I'm going to call this X, and it does say that it is the fastest 4%. So those are going to be the smallest times that you have because it's fastest. And this area here is 0.04. So in order to find that X value down here, we're going to use inverse norm. It's the area to the left, which is 0.04, our mean, which is 129.94, comma standard deviation, which is 2.28, and then enter, you get 125.9484 seconds. We have one more part on this. It says D. It says the middle 60% of her laps are from so many seconds to so many seconds. So again, I'm going to draw my normal shape curve, and I'm going to go ahead and do that problem right underneath here. So we have D, normal shape curve. Put your mean in, which is 129.94. Middle 60, so we're going to go ahead and shade the middle 60. There's two values, They're going to have the middle 60% are going to be in here. We'll call this one x1 and this one x2. And it wants us to figure out those two values. So let's go ahead and put a few numbers on here. This is the middle 60%, so this is 0.60. That means that the tails, the total area underneath the curve is 1. So 1 minus 0.60 is equal to 0.40, but it's split evenly among those two tails. So I'm going to divide by 2, and I get 0.20. That's how much area is in each of these individual little tails. So in order to find x1, we have to use inverse norm. And so we have x1 equals inverse norm. Area to the left of x1 is 0.2. The mean is the 129.94. And then our standard deviation is 2.28. And then x2 is the same thing, inverse norm. The area to the left this time is going to be both of these together. So we have area to the left of x2 is going to be 0.8. Mean is 129.94. Standard deviation is 2.28. Going ahead and selecting enter on both of these and typing those all in. The lower number is going to be 128.0211 seconds. And our upper is going to be 131.8589 seconds. So I want to bring to your guys' attention that not on all the questions, but on a lot of the questions, they have helpful videos that are going to show up for you guys to watch, or links. Helpful links is the other thing that you can have. Okay, there's another question on here that a lot of us had. And for this one, it says, assume that a sample is used to estimate a population proportion P. Find the 99 percentile confidence interval for a sample of size 341 with 13% success. Enter your answer in a trilinear equation using decimals, not percents, accurate to 3 decimal places. So first of all, this trilinear inequality just means that there's 3 things here. All that means. So there's a P and then 2 blanks, so those are trilinear, and that's just the wording that they use. So we need to know N, and N is our sample size, which is going to be 341. And then it says for X, which is our number of successes, we only have a percent of successes, so we have to do 341 times 0.13. And when we multiply this out, we get 44.33. We need this to be a whole number, so we need to round this. It just rounds down to 44. And then our C level, our confidence level in this problem, is 0.99. It's a 99%. Okay, so we are dealing with a confidence interval and proportions. So we are going to 1 prop z int. Put all your numbers in that are listed right up above. When you guys do this, you're going to hit enter, and you're going to get your lower bound, which is 0.082. It says to round 3 decimal places, and 0.176. So the numbers that you would write in are those into your confidence interval here. So we are going to have 0.082 for our lower bound. And for our upper bound, we're going to have 0.176.